GATE 2021 Civil Engineering Set 2 Question 38. A prismatic fixed beam modeled with a total lumped mass of 10 kg as a single degree of freedom system is shown in the figure. So we can see that we have a central mass m, which is called the lumped mass, and its mass is 10 kg. If the flexural stiffness of the beam is given as 4 pi square kilonewtons per meter, its natural frequency of vibration needs to be found in hertz. The relevant NPTEL reference has been listed. If we can see here, a single degree of freedom system is given, which is a sin omega t plus phi. For this system, we can find the natural frequency of the system as root over k by m. This frequency is called the natural frequency because it only depends on the characteristics of the system. That is the flexural stiffness and the mass. So since it depends only on the characteristics of system, it is called the natural frequency of oscillation. When we substitute the values, we would get the frequency in radians per second. In case we need the frequency in hertz, we should divide this quantity by 2 pi. That would give us the frequency in units of hertz. So as we saw in the question slide, the mass is given as 10 kg and this is a lumped mass. So this is a equivalent mass for the whole system, and the flexural stiffness is given as 4 pi square kilonewtons per meter. So converting this to units of newtons per meter, we would get 4 pi square into 10 to the power 3 newtons per meter. The frequency of oscillation is root over k by the lumped mass, that is the equivalent mass. This would be 4000 pi square divided by 10. This would give us root over 400 pi square, that would be 20 pi radians per second. But the question asks us to calculate the natural frequency of oscillation in units of hertz. So we would divide this by 2 pi to get the frequency in units of hertz. So that would be 1 by 2 pi into 20 pi that was obtained here. This would give us the answer as 10 hertz. So a prismatic fixed beam was given where the total lumped mass was 10 kg and the flexural stiffness was 4 pi square kilonewtons per meter. So for this single degree of freedom system, we obtained the natural frequency of vibration as 10 hertz. The relevant NPTEL reference has been listed here.